Okay, so last week we learned Newton's second law. Yes, there's an object that was moving with the velocity, initial velocity of v. Usually we take that u. Okay, I put that v1 or v0. Okay, so after t seconds of duration, the speed of this object, the velocity of this object has been increased up to v1. So that's v2. If you use that v0, that may be v1, but that's confusing. Therefore, I'm using that v1 and final velocity is v2. So this is due to an acceleration. You know that changing of velocity is an acceleration, yes, relative to the time. So this acceleration is always due to an external unbalanced force, as you learned in Newton's first law. Okay, so that's the same external unbalanced force. So that's a constant or uniform external unbalanced force. As a result of this, its object has been increased up to v2 from the initial velocity v1. Okay, so this is a kind of increase or whatever the change of velocity with the time, we call that acceleration. That may be minus or plus. Okay, if it is a minus acceleration, definitely that's a deceleration. If it is positive, that's an acceleration. Okay, whatever it is. So we have to consider under this process, yes, ability to move, yes, and reluctance to move. Reluctance to move is known as inertia. අවස්ථිතිය. යම් වස්තුවක් චලනය වීමට දක්වන නොකැමැත්ත. The reluctance of an object to change its state of motion. නිශ්චලතාවයේ තියෙන වස්තුවක් චලනය වීමට දක්වන අකමැත්ත හෝ චලනය වෙමින් පවතින වස්තුවක් නිශ්චල වීමට දක්වන අකමැත්ත. So that's reluctance of an object to change its state of motion. To change its state of motion is known as inertia. I think Newton's දෙවන නියමය, second law of Newton is associated with this inertia. Okay, so ability to move, this motion ability is measured with momentum. So momentum. So that means momentum equals mass into velocity. For instance, if an object moves with the velocity, the mass m, its velocity is v, therefore momentum is said to be mv. Okay, so momentum is mass into velocity. Simply we can write mv. Okay, so that's, you can see initially this object of which mass is m is moving with the velocity v1. Finally, the same object under the acceleration, it has achieved its final velocity v2 after t seconds of time. Therefore, its initial momentum is mv1 and final momentum is mv2. So we write initial momentum, so that's mv1. Yes, its final momentum, that's equals mv2. Now change of momentum mv2 subtraction mv1. Okay, so this is the change of momentum. But this change happens within t seconds of time. Therefore, the change of momentum per unit time, change of momentum per second, definitely we have to define this. So we have to divide this change of momentum by the time. Then we can end up with change of momentum per second. Okay, so change of momentum per second, we call that rate of change of momentum. Change of velocity per second, we call that rate of change of velocity. Rate of displacement per second. So likewise, so change, whatever the change that happens per unit time is known to be the rate. ඕනෑම වෙනස් වීමක් ඒකක කාලයකදී, ඒ කියන්නේ තප්පරයකට සිදුවන වෙනස අපි කියනවා ඒ වෙනසේ ශීඝ්‍රතාවය කියලා. කෙනෙක් කාගේ හරි උස වැඩිවීමක්, දිග වැඩිවීමක් තප්පර 10කට මෙච්චරකින් දිග වෙනස් වුණා. එහෙනම් තප්පරයකට කොච්චර වෙනස් වුණාද? So that's called rate of change of length. Likewise, rate of change of displacement, so that's velocity. Rate of change of velocity, so that's acceleration. Rate of change of momentum, so that's equals to what? Okay, let's discuss next. Rate of change of momentum, that equals mv2 subtraction mv1. Per unit time, you have to divide that with t. So this is known to be the rate of change of momentum. Rate of change of momentum. Okay, good. Now, according to the Newton's second law, he says the rate of change of momentum, mv1 to mv2 within t seconds of duration, and per unit time, that rate of change of momentum. තප්පරයකට සිදුවෙච්ච ගම්‍යතාවේ වෙනස. So that's directly proportional to the external unbalanced force exerted on this object. මේට වඩා ලොකු force එකක් apply කළා නම් තප්පරයකට සිද්ධ වෙන velocity change එක හුඟක් වැඩි. ඒ කියන්නේ මෙයාගේ v1 වලට සාපේක්ෂව ලොකු force එකක් දුන්නොත්, that's v2 is very high. So likewise, the rate of change of momentum is also directly proportional to the applied force. Directly proportional means when one variable is increasing, associated other variable also increasing. When one variable is decreased, associated other variable also decreasing. So that's the rate of change of momentum is directly proportional to the external unbalanced force applied. So, but according to Newton's second law, yes, so you have to go there. External unbalanced force F is directly proportional to the mv2 subtraction mv1 over t. So this is known as rate of change of momentum is directly proportional to the external unbalanced force F. But you can equalize this by keeping a constant. F වැඩි වෙනකොට rate of change of momentum වැඩි වෙනවා. It's okay. When you decrease this external unbalanced force, එතකොට මේ velocity වෙනස් වෙන්නේ බොහොම අඩු. mass එක කොහොමත් constant. බර වෙනස්, mass එක වෙනස් වෙන්නේ නැහැ, ස්කන්ධය වෙනස් වෙන්නේ නැහැ නේ object එකේ. So that's depending on the magnitude of the force applied. So final velocity or the velocity change that happens within a second. තප්පරයකට සිද්ධ වෙන velocity change එක යොදපු පෝස් එක මත බලපාන නිසා අපි කියනවා මෙයා වැඩි වෙද්දි මෙයාත් වැඩි වෙනවා. එහෙනම් ෆෝස් වැඩි වෙනකොට කී ගුණයකින්ද වැඩි වෙන්නේ? එහෙම වුණොත් ෆෝස් එකට සමානයි mv2 subtraction mv1 upon t times k කියලා ගන්න පුළුවන්. k ගුණයක්. mv2 subtraction mv1 over t. Yes, directly proportional means එක variable එකක් වැඩි කරනකොට අනිත් variable එකත් වැඩි වෙනවා. එක variable එකක් අඩු කරනකොට අනිත් variable එකත් අඩු වෙනවා. කී ගුණයකින්ද? කී ගුණයකින්ද කියලා හොයාගත්තොත් සමාන කරන්න පුළුවන්. එහෙනම් so that's external unbalanced force is k times constant. A constant time mv2 subtraction mv1 upon t. But Newton has defined but k equals 1. Newton බලය මනින ඒකකය define කළා k සමානයි එකක් වෙන විදියට. ඒක එහෙම හිතාගන්න. Newton has defined the force measuring unit Newton as this k becomes 1. So that's by the definition. Therefore, force equals mv2 subtraction mv1 over t. But you can see v2, you can take this mass out. F equals common factor m v2 subtraction v1 over t. Okay, but you know v2 subtraction v1 over t, that's equals the acceleration. The rate of change of velocity, so that equals to the acceleration. You know that acceleration equals delta v over delta t. Here delta v means v2 subtraction v1. Directly we have been given this time t. Okay, so you can see v2 minus v1 over t equals acceleration. Therefore, F equals mass into v2 minus v1 over t means acceleration. F equals ma. So last week we quickly did that, but we could not write it down. So now I ask you to take this proof. I'll give you only 3 minutes. Okay, simply now you can calculate the exerted external unbalanced force magnitude. Okay, if the mass of this object is, if the mass of an object is given as 5 kilogram and it is subjected to the external unbalanced force F, so its initial velocity V1 equals 2 meters per second. Due to this external unbalanced force, this object has displaced, increasing its velocity up to V2, that equals 12 meters per second. Yes, time taken T equals 8 seconds. Yes, you can calculate the acceleration of this object. Acceleration equals rate of change of velocity, or so that's delta V over delta T. So that's V2 subtraction V1 over delta T. So that has been directly given us the time change. So V2 is 12 subtraction V1 is 2. And the time taken for this is 8. So you can subtract, or you can simply cut this. So that's 5 over 4. So you can end up with 1.25 meters per square second. Yes, if you know the acceleration, you can calculate the external unbalanced force as well. So usually they are asked in exams. So these details are given, calculate the acceleration, and then you have to calculate the force. Sometimes this acceleration is not given to you and that's not asked. If it is asked in the exam, you can answer and then you know this acceleration quickly and you are directed to get this answer. But there are some hidden questions. They directly ask that external unbalanced force. In that case, you have to know, we have to find this acceleration first, then only we can substitute to that Newton's second law equation, F equals ma. But when you apply this F equals ma, you have to apply it to the direction of the motion. Suddenly, if this value is changed minus, it intends this force exerted to the opposite direction. Okay, now mass of this object is 5 and the acceleration we have already calculated as 1.25 meters per square second. But in physics, we do not put units at middle steps. So we have to put that only to final step. Okay, so 5 times 125. So that's 125. So that's 600. Okay, 5 times 5, 25. 2 remains. 5 times 2, 10 with this 2, 12. 5 times 1, 5 with this one, 6. Yes, so that's how you get that progression. So that's 2 decimal places. So 6.25 newtons. So that's the answer for this. So the magnitude of the force applied on this object is 6.25 newtons. And here also the same force. That's why we call that constant force, constant external unbalanced force. As a result of this, you could get this one. But these types of questions are not easy as this example. Okay, now take this down. Okay, example 1. The second example, let's take down. Here is the object. F1 force, so that's 25 newtons. And there's opposite force exert on this object. That's F2. So that equals 5 newtons. Okay, so that's towards the opposite direction. Mass of this object is 4 kilogram. Yes, first question under that. Calculate the external unbalanced calculate the external unbalanced force. Second question. Calculate the acceleration of the object. Yes, first question, to calculate the external unbalanced force, if unbalanced, and is similar to the resultant force. Resultant force. So we can denote it as FR, resultant force or unbalanced force. Yes, look at this. External unbalanced force, F resultant equals F1 plus F2. But this force is a vector quantity. Therefore, you have to consider the direction. Usually you consider positive direction your right hand side and negative for your left hand side. This F1 force is to right direction and F2 force to your left direction. Therefore, you have to consider that direction when you substitute values. You can see that's F1 is 25. 25 but positive plus F2. Look at this. F2 is 5 newtons but opposite force. Therefore, we have to apply that's minus value for that. Yes, you can end up with the resultant force is 20 newtons positive. Although 5 newton against this forward movement, F1 is 25 newtons and F2 is 5 newtons. Yes, F1 is then 20 newtons more than F2. So therefore, this object accelerate with that excess amount of Newton values. So this 4 kilograms of object going to be accelerated with that additional force more than F2. So what's the additional force here? So that's 20 newtons. Although this 5 Newton tries to stop this, so it can be overcome by spending 5 newtons to this positive direction. So what remains after overcoming this F2, 20 newtons remains. So therefore, this 4 kilogram object is going to be accelerated by 20 newtons of resultant force, not by 25. Therefore, yes, second question, calculate the acceleration of the object. So this object will be accelerated by this additional 20 newtons. That means resultant force. So acceleration is what? So for the calculation of acceleration, you have to make a statement to calculate acceleration by applying F equals ma, Newton's second law equation, to the object. So now you are going to apply, that's F equals ma. So this F is nothing but resultant force as explained by Newton, not this 5 or not this 25. So that's resultant force, because resultant force is the force that affects to the change of acceleration. Okay, actually to change the velocity of this object as a result of this, it achieves this constant acceleration. So therefore, the responsible force is not F1, not F2, but this resultant force. Therefore, you apply 20 equals, so that's positive direction. So that's why we put that positive 20. So mass is given as 4 kilogram. So 4 into A. Therefore, you can subject this A equals 20 upon 4. So your answer is equal to 5, this acceleration, 5 meters per square second. 5 meters per square second. Okay, take the answer. So this is our second example. If one force exerts of an object, here there's F2 force. Yes, under these two forces application, this object of which mass is 5 kilogram, yes, it has achieved the acceleration to the positive direction. Yes, that's 2 meters per square second. Okay, so if this F2 force is 5 newtons, yes, our question First one, calculate the F1 force. Calculate the F1 force. Simple question. Yes. First of all, you have to mention, so what's the law you are going to apply here? So you have to tell by applying Newton's, by applying Newton's second law to the motion of the object. Yes. You know that F equals ma, but this force is actually external unbalanced force. So that's F resultant. Therefore, you know that F resultant equals, yes, F1 plus F2. F1 is to positive direction, F2 is to negative direction. So you can simply substitute this one. So that's very easy. It will be like this. F resultant F1 plus F2 equals mass into acceleration. Okay. So this is positive, this is negative. So F1 plus F2, yes, that's 5 Newton, but to the opposite direction 5, equal mass is given. It's also 5, and you can calculate the acceleration now that has been given. That's 2. Okay, now you can calculate F1. F1 equals minus 5 goes to the other side as an addition. 5 times 2, that's 10. 10 plus 5, so that becomes 15. That's 15 newtons. So this same calculation you can do in 2 steps. Yes, you know the mass, you know the acceleration. Therefore, directly by applying the second method, so this method 1. So method 2. Yes, by applying F equals ma, you can directly calculate this resultant force by using mass is 5 kilograms and acceleration is 2. So you can end up with 5 into 2, so that's 10 newtons. Okay, so that's resultant force is 10 newtons. But you know that resultant force, but F resultant equals F1 plus F2. Therefore, F resultant, as you have calculated this 10 Newton, 10 equals F1 is to be calculated, just that you keep that as F1. F2 is, yes, that's 5 Newtons. That's 5. Okay, now you can substitute this F1, then you have to get this plus 5. Yes, that's a problem here. Plus 5, actually that's to the opposite direction. Therefore, you have to put that there, minus 5. Okay, so because this is to the negative direction. Some of you may confuse, sir, this F2 is in the positive side. No, we do not consider the side where this force exists, but the direction of the force to where it is exerting. So therefore, you have to use that minus 5 here. Okay, now F1 equals minus 5 goes to the other side as addition 10 plus 5, then F1 equals 15 newtons. So this is the second method. After you calculate the resultant force, then you can find the rest of the forces in the system. Okay, I think all of you have quickly taken this down. Right. Motion of an object has been given by following VT graph. This is your typical VT graph, a roof, mass of the object is 10 kilograms. Yes, its velocity also has been increased from 0 to 10 meters per second within 5 seconds of time. Yes, first question. Calculate the external unbalanced force of the object within first 5 seconds of duration. Yes, second question. Force I use the symbol resultant force from 5th second to 10th second. Okay, you have to calculate that value. Resultant force from 5th second to 10th second. Yes, next question. Resultant force from 10th second to 12th second. F resultant. Yes, 10th second to 12th second. Okay, so these are the questions you have to do. And motion description has been given in a velocity time graph. Yes, after this lesson, both physics and chemistry, yes, it becomes somewhat complicated. Uh, not that sweet questions given to cheat you. So we have to learn this after this much deep. Yes. Don't hesitate when you do this calculation. Calculate the external unbalanced force of the object within the first 5 seconds of duration. So whatever the duration, we have to use Newton's second law equation. Therefore, you have to tell it first by applying F equals ma to the motion of the object from 0th second to 5th second, from 0th second to 5th second. By applying F equals ma to the motion of the object from 0th second to 5th second. Okay, now let's see. First, you have to put this F equals ma. So what are the things you require? You require mass. It has been given as mass is 10 kilograms, so we know that. Then you have to calculate the acceleration to find this resultant force. So directly that acceleration has not been given. Therefore, you have to find it by using the graph. In velocity time graph, how do you calculate the acceleration? So that's by the gradient. Therefore, first you calculate acceleration equals gradient. Gradient equals, yes, delta y upon delta x. That means change of y over change of x. So what's the change of x? 0 to 5. That means x2 subtraction x1. So corresponding y2 subtraction y1. When this x change from x1 to x2, y change from y1 to y2. Therefore, to take the change, you have to subtract the initial value from the final value. So you can see change of x is 5 subtraction 0. So corresponding y values 10 subtraction 0. Then the answer is 10 over 5. So that's 2 meters per square second. Now you know the acceleration in the first 5 seconds of duration. Therefore, you can substitute that in this F equals ma. Okay, F equals ma. M is 10, acceleration is 2. You can see that external unbalanced force is 20 newtons. යනවුන්ට එක්ක physics බෑ එක්කුන්ට ඉංග්‍රීසි බෑ. So last 2-3 weeks, due to the power failure, I could not admit to the class totally. That means, so I joined to the classes, but power comes and went like that. So, sir, can you upload the videos of motion in straight line, biosphere, tissue lessons to the group? Yes, I have already added those videos, but I think last week video still to be uploaded. I'm also facing a problem here because when I'm going to upload that daytime power cut, I have to face. So I can't use battery backup at that time because in that time it is being charged. So if I use the backup for uploading, I can't do that evening classes because under power cut, I have to use the battery backup. So that's my problem. Daytime සල මට වීඩියෝ අප්ලෝඩ් කරන්න පාවිච්චි කරන්න බැහැ බැටරි. එහෙම වුණොත් එහෙම හවස පන්ති කරන්න මට පවර් නැතු යනවා. හවසත් පවර් කට් එකක් එන නිසා. ඒකින්ද අපි පුළුවන් විදියට පහුවෙලා හරි මැනේජ් කරගෙන යමු වීඩියෝස් ටික. දැන් අදත් පවර් කට් කිය සමහර අය යනවනේ. අද මම දන්න තරමින් පවර් කට් නෑ නේද? no power cut I think. Okay, have you ever experienced a power cut today? The power cut එකක් experience කරපු අය නැහැනේ?
No, sir.
No, not today. ඉතින් මේ power failures තියෙන්න පුළුවන්, not power cut. Okay, but I think that will be okay. හැමදේම වෙන්නේ හොඳටනේ. දැන් COVID එනවා. COVID comes to select good teachers. නේද? Teacher strikes comes to understand actually they are teachers. Doctor strikes comes to understand actually they are doctors. Nurses strikes come in to understand actually they are nurses. So all the things depends on money. No one can get rid of that. හැමෝටම මුදල් වලින් ගැලවෙන්න විදියක් නැහැ. ගැලවෙන්න නම් හුඟක් දේවල් අතාරින්න වෙනවා. Okay? So I think no one can do classes like me because they are bound to do something. හුඟක් මිනිස්සු හුඟක් දේවල්ට බැඳිලා ඉන්නවා කරන්න. එතකොට මේ වෙලාවේ සමහර මිනිස්සු බුදියන්න බැඳිලා ඉන්නවා. හරි? If not, family life is sorry.com. But nowadays, not only today, but I am doing this many years. Okay? So this is only 2-hour classes. So I think I don't consider this much as a big dedication. But early days, I did classes from evening 6 to next day morning 6. Evening 6 to next day morning 6. So yes, all over the night. Then also students came to my classes. Yes, hundreds of students, full of halls. But I feel now, yes, something has happened to the syllabus as well as something has happened to the mind of students. So they are automated. So I'm not going to explain it because you know that situation. Okay, so resultant was 5th second to 10th second. So you can find this gradient. Actually, there's no gradient. Okay, you can calculate that here. Yes, before applying F equals MA, you have to find this acceleration. Okay, so let's do that. Acceleration, 5th second to 10th second. So that's delta y upon delta x. That means x2 subtraction x1 corresponding y2 subtraction y1. Yes, x2, x1, you have to substitute that first. 10 subtraction 5. Yes, 10 to 10. And 5 to corresponding y value 10. So 0 upon 5, that's acceleration is 0. Therefore, resultant force, if resultant force equals mass into acceleration, mass is 10, that's okay, but acceleration is 0. Therefore, no resultant force, no external unbalanced force, that's 0. That's why we always tell, if there's no acceleration, no external unbalanced force, ඒක මෙතනත් ඔප්පු වෙනවා. ගණිතේනොත් ඔප්පු කරන්න පුළුවන්. Definitely, if there's an acceleration, there is a external unbalanced force. On the other hand, if there's an external unbalanced force, it's sure that, it's cocksure that surely this object will be accelerated. It is crystal clear. So you have to believe it like a religion. Okay. So if there's an acceleration, definitely there's an external unbalanced force. If there's an external unbalanced force, definitely there is an acceleration. Okay. Good. I think last one, you can see that there's an acceleration, but that's minus. Okay, let's see. Puta, if an object is moving to the positive direction, its velocity is gradually decreasing. So velocity is gradually decreasing. Therefore, external unbalanced force, or if resultant, has been exerted on this object to the opposite direction of the motion. Okay, so here's the velocity decreasing. That's due to this opposite force. So without understanding this clearly, also you can do this calculation, and after you end up with the answer, you can realize that. So that's the logical behavior of these types of physics calculations. Before the understanding or after the taking the answer, you can understand. Before you can understand by thinking logically, and if you just calculate, and when observing the final answer, you can understand it secondly. Okay, both methods you can apply. First of all, next, you have to calculate the acceleration 10th second to, yes, acceleration, yes, under third question answer. First you calculate acceleration from 10th second to 12th second, or you can write this by words, it doesn't matter. So that's equals gradient of the graph. Gradient equals delta y over delta x. Please don't write this in your exam or in your school teachers' calculations. Okay, they don't like this. So that's change of y, y2 subtraction y1, but I recommend you to substitute this x2 and x1 first. Yes, x2 here, now x2 is 12, subtraction x1 is 10, corresponding y values 12 to 0, 12 to 0 and 10 to 10. Yes, you can end up with minus 10 over 2. So that means minus 5 meters per square second. Minus 5 meters per square second. So this is the acceleration in final 2 seconds of duration, a kind of deceleration. Okay, so you can't do this calculation by words. Therefore, that idea of deceleration must be embedded in this minus mark. Then only you can take the answer logically. Okay, so let's substitute this here. F equals ma. Before that, you have to tell that by applying F equals ma, by applying F equals ma to the blah blah blah. So that means to the motion of the object. So you have to put here. So no space, therefore I don't write that. So you have to put that. By applying F equals ma to the motion of the object, so that F is to be calculated. Mass is 10, acceleration minus 5. Yes, that external unbalanced force is minus 50 Newton. What does it mean by this minus 50? Minus 50 Newtons means, look at this, its velocity gradually decreases due to that force is opposite direction to the motion direction. Therefore, it has been decelerated and we can find the value minus 50 newtons. External unbalanced force is minus 50 Newton. That means that's an opposite force. Sometimes in questions, you are questioned, yes, describe the direction of this external unbalanced force. Then you have to tell this object is exerted minus 50 newtons of force, or you can tell 50 newtons of force has been applied to the object opposite to the direction of its motion. Okay, can you understand this, Tirunad? Can you logically understand what's going on here?
Yes, sir.
Okay. මේක ලංකාවේ කොහරි තැනක මේ ගාන හදනවා නම් වහා මටපට්ටමට කියන්න. If someone is doing these physics calculations like this to give that concept to your brain, please tell me. I thoroughly say no one teach you this as no one knows. I thought I have sent this to all the groups that invite message. How's that? I have sent only the picture to some groups. Okay, if there any newcomers, send me the message in new කියලා message එකක් කරන newcomer කෙනෙක් ඉන්නවා නම් එහෙම ඉන්නවා නම් ඒක කලාතුරකින් සිද්ධ වෙන දෙයක්. No one will wait until these questions without knowing motion graphs. Okay, so quickly take down. If you need, you can take print screen, because I don't promise you to send this video, because next day another 7-hour power cut exists. I don't know when it will be. No time for this power cut. I can't adjust my time. Good. I think all of you can understand this concept of motion and Newton laws. No one knows, so all of them are interrelated. Some of them think that resultant force is another thing. External unbalanced force is another thing. Motion graph is separate thing. So they don't know the interconnection in between them. So that's the conceptual thing you have to keep in your mind. Okay, you have to understand the importance of this velocity time graph for the motion. Okay, this velocity time graph explains clearly the motion of an object and what's the reason for that motion, for the acceleration or deceleration or for the uniform velocity. Yes, until you logically learn this calculation, unless an external unbalanced force exerted on an object, until an external unbalanced force exerted on an object, it will be accelerating. It travels under an acceleration, or till an external unbalanced force is exerted, that object remains at a uniform velocity. You saw that under this uniform velocity, that external unbalanced force becomes zero. Yes. Until an external unbalanced force is exerted, it remains at a uniform velocity or stationary state. Okay, let's learn another one. There's another lesson called friction. Friction is just another type of force. If you like, you can consider it as F1 or F2, but usually we use that F dash. An object was moving at a velocity of V naught. Okay, but suddenly it changed its motion to a rough surface. So here's we consider as smooth surface. Smooth surface. Velvet ගලනන්නේ ඒ වුණාට friction එකක් තියෙනවා. Okay, smooth surface can be considered as that's not in this world, but that exists in, yes, ice is somewhat smooth, but not completely. There's a friction in ice too. In universe, there's no surface, but we consider that frictionless medium. Yes, velocity v naught. Due to this object move to the rough surface, frictional force F dash is exerting on that. As this friction is under motion, so we call that dynamic friction. Dynamic friction. Gatika Garshane, dynamic friction. So you have to calculate this according to the motion description given in this VT graph. Its velocity maximum velocity, it was moving at uniform velocity that was 20 meters per second. So you have to name the axis and units. After 10 seconds of duration, this object has completely come to the rest by decreasing its velocity up to 0. Okay, so you have to calculate first. If the mass of this object is 10 kilogram, first one. Okay, do this calculation. Yes, another question I'll give you, but theories are not covered for that. But basic theories, you learned that in grade 8. So I'll give you a hint. Work done equals force into displacement. The only equation you have to apply is F equals ma Newton's second law equation. But for that, you have to know the mass and acceleration. Acceleration is not directly given to you. So it has been given by a velocity time graph. So simply you can calculate the acceleration by calculating the gradient or find the gradient of the graph. Okay, calculate the f dash. So you can simply calculate external unbalanced force equals mass into acceleration. Yes, but you don't know this acceleration. Therefore, acceleration equals gradient. Gradient equals delta y over delta x. That means y2 subtraction y1 over x2 subtraction x1. Yes, y2. First substitute these x values. 10 subtraction 0. That means 10 to 0, 0 subtraction 20. Yes, minus 20 over 10. So that's minus 2 meters per square second. So that's the acceleration. So therefore, F equals ma, mass is 10, acceleration is minus 2 meters per square second. Yes, that's minus 20 newtons of external unbalanced force. There's no any other forces because it was moving at a uniform velocity. But because of this rough surface, it creates opposite force to stop this object by the mutual surfaces in contact. By the mutual surfaces in contact. එකිනෙක සමග අන්‍යෝන්‍ය වශයෙන් ස්පර්ශ වී ඇති පෘෂ්ඨ මගින් ඇති කරන ඝර්ෂණ බලය. So by the mutual surfaces in contact, frictional force is created against the motion. It can be calculated. So that's only force. So that's minus 20 Newton. So always friction is against to the motion. Therefore, we can end up with minus value for this force. But F equals F dash this times because no any other forces. එකම external unbalanced force එකේ තන friction එක පමණයි. Yes. So this is minus 20 newtons. Calculate the work done by the object to overcome friction. So that's work equals force into displacement. That force is minus 20 into displacement. Yes, displacement can be calculated in velocity time graphs. So displacement is area under the graph. Okay, area is half into base into perpendicular height. So that's half into base is 10, perpendicular height is 20. Yes, 10 times 10, 100. Minus 2000 joules. So what does it mean by this minus 2000 joules? Actually, this minus 2000 joules of energy has to be spent to overcome this friction. Friction එක මගින් friction එක මැඩ පවත්වන්න අපිට කරන්න වෙච්ච කාර්ය work එක. So therefore, that gives a minus value because we have spent that energy to overcome that. Okay, so take this down. Yes, I want a simple remark. මට ඔයගොල්ලන්ගේ අදහස් දැනගන්න කැමති අද දවසේ හදපු ගණන් ටික ගැන. Could you understand that it was important, it was easy to understand, it was somewhat complex, so we have to practice it again. Okay, so promise me to watch them again. So likewise, you can give a comment now by a message. Can understand. understood well. It was Ginigindara, but I have to practice more. I could understand well, clearly understood very well. I'll promise to watch video again. Understood, could understood. That question somewhat complex, but we understood well. And I watched the video again. Good. So thank you for turning midnight oil for learning this. So this is the feasible undisturbing time in this power cut season. Therefore, try to get used to that. Okay. No aberration, no obstacles, no obstructing sounds produced by television. So whatever the audio setups. Okay. Therefore, yes, thank you so much for the participation. I'll send you this video as quickly as possible. Okay. God bless.
Thank
Thank
you,
you,
sir.
sir.
Good
Goodbye,
night.
sir.
Thank you, sir.
Good night.